Woohoo! It's a great day to learn some geometry. I'm Miss Lake Battles, and I'm here today to talk to you about geometric solids. The first kind we have are also called polyhedron because all their faces are polygons. Have one here. This is a hexagonal prism. All prisms have rectangular lateral faces, and then they have two bases that are parallel and congruent. Hexagonal prism. Here I have another prism, has a special name. It's a cube. A cube is also a prism, and a cube has another name. Do you know another name for a cube? It's called a hexahedron, and it's because every single face are congruent polygons, in this case squares, and hexa means six, so there's six congruent faces that are squares. Here I have a triangular prism. Uh-oh, what happened? Looks like somebody sat on it. No, nobody sat on it. It's still a triangular prism, but it's called oblique. It still, if we straighten it back up, would have the same height and the same basis. So when we talk about volume, that's not going to make any difference for those that are oblique. Now, we also, when we talk about these, we're going to also talk about cylinders. A cylinder is just like a prism. Look how much it looks like this hexagonal prism, but it's a cylinder. It has a circle base instead. And likewise, we're going to talk about other polyhedron, which are pyramids. These are pyramids. If I just say it's a pyramid, it means it's a square pyramid because that's the common pyramid. This is a triangular pyramid. But when we talk about pyramids, we're also going to talk about cones, okay? Because a cone is just like a pyramid, but it has a circular base. Some other solids that we're going to talk about is, of course, this. You know what this is. You might call it a ball, but in geometry, we're going to call it a sphere. And this is a half of a sphere, and it has a special name. Maybe you studied it before when you studied the globe or the earth. Northern hemisphere, southern hemisphere. So a half of a sphere is called a hemisphere. You know, we have solids all around our house. Here's a solid. Look, it's my box of crackers. It's my favorite kind. It's a rectangular prism. I'm going to make a red velvet cake, and I'm going to ice it with this cream cheese icing. It's in a cylinder. So we have solids all around us all the time. Another thing I want us to talk about are these two-dimensional shapes that fold to make a three-dimensional. You know, all the geometric solids are three-dimensional, but what if we had something flat, like that cracker box I showed you? When we make that, it's flat, and then we fold it up into that box. Well, I have one here. It's a two-dimensional figure, and it folds up to make a three-dimensional. Look what it makes. It's a hexagonal prism. The cool thing is, when you straighten it out, you can see these two hexagon bases. When we fold it up, they're parallel and congruent. And then here are all those lateral faces. They're all rectangles, remember, like we talked about before. So, again, if it's a two-dimensional that folds to make a three-dimensional, it's a net. I've got some others to ask you about. What about this? What do you think it would fold up to? Well, it has all triangle faces. So look, for pyramids, the faces, those lateral faces, are always triangles rather than rectangles, like they were for the prisms. So this is a triangular pyramid. They're always named by their bases. And I have another one here. This is that common pyramid. This is the square base. Here are those faces. I'm going to fold it up. There's my square pyramid. I have some that are more interesting. Look, this looks really mathy What about that? Okay, it looks like a division symbol, but it's a net. It's a two-dimensional figure that folds to make a cylinder. Okay, what about this? This has got to be the most unusual of them all. What is this? What do you think it'll fold up to? Let's fold it up. Oh, that's interesting. What is that? Folds up to make a cone. That was a net, N-E-T, net, for a cone. Now, next, I want to talk about something called cross sections. And I have a model. You're probably familiar with these Post-it notes. So it's a rectangular prism. And then I took this plane and passed it through. Okay? A cross section is the intersection of a three-dimensional shape like this rectangular prism and a plane. When you pass the plane through it, what would the intersection be? What would that intersection look like? And in fact, if you pass it right through here, that intersection would look exactly like this. It would be a square. Okay, so a cross section, it's like a little slice out of the solid. And you know, that really helps us when we get ready to find volume. So think about this little cross section. That would be this, the area of this would represent the area of this base. And then if we multiply by the height, how tall it is, it would give us the volume. This two-dimensional figure times the height, which is one-dimensional, will give us a total three-dimensional figure. So the volume is a three-dimensional measurement. It's measured in cubic units. So I've laid that out for us in this. This is a volume for a prism, just like what I just looked at. The volume of a prism is capital B, which stands for the area of the base. Remember that orange square? And then times the height of it. Notice H is lowercase. It's very important that it's lowercase. And when you multiply that, uppercase times the lowercase, 2 dimensions times 1 dimension gives us that three-dimensional figure. So we're going to get cubic units. Now, what about our cylinder? We talked about cylinders the same time we talk about prisms. And I made one for that too. The volume of a cylinder is, look, instead of a capital B here, it's the area of that base, which is the area of a circle. Pi r squared sounds like area to me. So pi r squared times H, that gives me the volume of a cylinder. Now, in our study, I just want you to be very careful when we talk about prisms, because sometimes students miss the problem when it shows them on their side, because we need the height, which is the area between, the height is the length between the bases. So when it's on its side, students want the height to be up and down. So just remember, if you have a prism and it's on its side, you have to be cautious, because when it's on its side, when a prism's on its side, the prismers might escape. Okay, I know you've been missing me. I've been missing y'all. I hope this helps. Remember, you're going to have some questions to answer for me, and hopefully we've covered all that on the video today.